Hello and welcome to the Daily Space for today, Tuesday, October 29th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Most Mondays through Fridays, either I or my co-host, Annie Wilson, will be here, bringing you a quick rundown of all that is new in space and astronomy. And today our story takes us all over the world. And most importantly, our first story takes us 1 mile underground, deep beneath the hills of South Dakota. There is a gold mine, and they will be searching for, dark matter, something far more elusive than gold deep down in that mind. In a news release from University College London, we learn that the Lux Zeppelin Experiment has been lowered 4,850 feet down a mine shaft. From its new resting spot, it will search for the particle signature of weakly interacting massive particles. These particles are theorized to be one of the possible components of dark matter. Our universe is made more or less of 3 different kinds of stuff. There's the normal material, baryonic material, that we are made of. This is less than just 5% of the universe. There's also dark energy, which no one knows what is, but it still makes up 68% of the universe. Finally, we have dark matter, which makes up 27% of the universe and is some kind of non-interacting particle. While we can readily map dark matter through its gravitational interactions with light and matter, scientists have so far been unable to study individual particles of dark matter and figure out what it's composed of. The Lux-ZEPLIN project hopes to change that. This detector consists of a central detector embedded in a tank of scintillator liquid that is in turn surrounded by a layer of water, all of which is buried underground. It is hoped that the nearly mile of dirt and buffer of water will absorb or deter all regular particles from reaching the scintillator liquid, while allowing dark matter particles to readily penetrate the system. Scintillator fluid, in this case liquid xenon, will be chilled to minus 148 degrees Fahrenheit or minus 100 degrees Celsius. And this material should give off light when it interacts with dark matter particles, which should be among the only particles to reach the fluid. While dark matter is thought to mostly not interact with regular matter, it should sometimes interact, and sometimes is enough if you have a sensitive enough detector. At this point, the Lux Zeppelin detector is still under construction. And we are bringing you this story because sometimes the construction that goes into creating one of these instruments is almost as amazing as, some of the science we expect to come out of it. In this case, a global science team constructed a 2,000 kilogram instrument out of ultra radio pure titanium in a clean room, wrapped it in plastic, put it in a transport structure, wrapped all of that in more plastic, and then lowered the entire thing into a mine where it was, moved into a new clean room that was waiting to take delivery. To make sure they could successfully move this instrument, they also constructed 2 dummy instruments and practiced moving those. That's a whole lot of thousands of kilograms to be moving around. Now that the instrument has, made its way to the bottom of the mine, the next several months will be spent wiring and cabling everything, making sure all the vacuum seals work well, and then testing the generation of liquid xenon. This project is planned for completion in the summer of 2020. And here's to hoping they find dark matter particles shortly thereafter. Switching slides. From nearly a mile underground, we now travel to a facility, more than a mile above ground. There is a new detector designed to detect dark energy that is getting installed on the 4-meter Mail telescope at Kitt Peak National Observatory. This is DESI, the Dark Energy Spectrograph Instrument. And, well, this instrument is designed to measure the distances to millions of galaxies across 1/3 of the sky. And this instrument is going to get used to map how our universe is expanding as a function of time. Um, this instrument has 5,000 little robots that position fiber optics. That's what we're looking at in this instrument. And those 5,000 little fiber optic cables, they send all of the individual light from all of the galaxies that are being looked at down to spectrographs that then, well, study the expansion rate, the recession rate of all of these galaxies across a myriad of distances. Constructed from components designed and manufactured by a collaboration spanning 75 institutions and 13 countries, DESI has been several years in the making, requiring 18 months just to be installed on the telescope. Now it has seen first light, and it's ready to start taking on the universe's greatest mysteries. Well, DESI won't directly detect whatever the heck dark energy is. The measurements it will make will document the effects of dark energy in unprecedented detail. And like surveys that have come before it, DESI will also allow us to do ancillary science to study galaxies in all kinds across all time. DESI is expected to enter full science observations in early 2020 and will take 5 years to complete its survey of more than 37 million objects. This is your reminder that astronomy is a field for those capable of handling very delayed gratification. And actually, it's not just astronomy that makes researchers wait. Planetary science is also full of, well, long months and years of waiting. And sometimes the results of that waiting aren't fully satisfying. Pluto is a case in point. When New Horizons arrived at Pluto 9.5 years after its launch, it captured amazing images of the heart of Pluto. While this feature and the surrounding features on that one face of Pluto have led to numerous insights and research papers, this is only one half of this dwarf planet. And half a planet isn't as satisfying as a whole planet. New Horizons was able to image Pluto in the lead up to its 4th of July flyby, however. And as this distant world rotated, the spacecraft obtained images of Pluto's other side at greater distances and thus at lower resolutions. In the 4 years since the flyby, New Horizons team scientists have been poring through this lower resolution data and working to find ways to combine it to get out every possible detail and every ounce of science. In a new paper posted on Archive, Alan Stern and company have posted this new imagery and proposed names for the features they see in their maps. These features include a bullseye of a crater named Simonelli. In addition to this, they have also seen a variety of linear features that are directly opposite or antipodal from the heart-shaped Sputnik Planitia. This new paper goes into potential geologic causes for the different features, and we will do a deep dive into these results next Monday, so stay tuned. I guess even this show sometimes is about delayed gratification. And that rounds out our show for today. Thank you all for being here. I am now going to hang around and take your questions. While you type them in, I'm going to remind you to please use that purple circle with a purple star in the center to mark your questions. While you type them in, I'm also going to remind you that the Daily Space is produced by Susie Murph and is a product of the Planetary Science Institute. The Planetary Science Institute is a 501c3 nonprofit dedicated to exploring our solar system and beyond. This means that your bits, your donations, your patronage is tax deductible where the law allows. Okay, so let's see what we have for questions this Halloween week. I'm scrolling up to the top. Yes, Eddie is being very sleepy on the very cool floor here in the basement. Hello, everyone. Welcome, so many of you. Mythtown, why are you saying moo? Why? Um, um, I love Trucker Kev, South Dakota, been there, done that reference. Um, yes, I am totally wearing a great pumpkin shirt for Halloween. Um, I love, I love Halloween. Hello everyone again. Oh, Guido, are you already on daylight savings time? We will catch up to you eventually. We really will, I promise. Is this real? Veronica, what do you mean, is this real? So many things are real, so many things are fake. But if you're more specific in your question, I might be able to help. So Larry Weird asks, what is radio pure titanium? It is titanium that doesn't have impurities in it that give off signal or radiation, from the best of my understanding. I also hit that term and did a quick Google search. It was very quick though, so better Google search may be required. Guido is talking to Susie. CosmoQuest, what does it look like? I'm assuming that you're asking what the Lux Zeppelin instrument looks like. Well, currently it looks like a big barrel surrounded in plastic wrap. Um, I don't know if they've actually gotten any good pictures of it because it's always been in a clean room. They've done everything they could to keep it completely enshrouded. I'm sorry. I'm sorry. Today is my day of not being able to answer questions. Um, oh, JWST slipped 2 months in schedule. Huh. Okay. Larry Weird comments that regarding the Pluto story, Simonelli crater sounds smelly. It is true. It is true. Not seeing a whole lot of questions. Kerbal is asking, is there a nebula that looks like a pumpkin? Not so much that looks like a pumpkin, but there is a nebula that looks like a screaming face. I actually have it slated to be in our daily space on Thursday. So stay tuned for Thursday and you'll see that, well, scary face in the sky. Titanium made before 1945. Okay, so Kerbal's Radio Pure Googling of titanium matched mine. So the way to think about it is if you want to build steel instrumentation that doesn't give off its own radioactive signal, you have to use metal that was created or mined or purified prior to the 1945 detonation of nuclear weapons on the surface of the planet. Things since then have all been contaminated with the background radiation that is still in our atmosphere. So people will actually go through and find steel that is from prior to 1945 and repurpose it in modern instrumentation. This is something that we have to deal with titanium as well. Oh, you guys aren't seeing the pictures. Dang it. Hold on. I'm sorry. I'm suffering from a very special form of fail. Okay, so here is Pluto. Let me go back. It's going to be that kind of a day, folks. Scrolling back. So here is our plastic covered Lux Zeppelin instrument. Here is the DESI instrument, and here is its first light image. Let me see if I can embiggen that. No, I can't with that. That will do it. I now somehow have succeeded in getting picture in picture. So I'm not going to actually transition to that. So there is the DESI first light image. There is Pluto in all of its gorgeous heart-shaped goodness. And there is the other image of Pluto. I'm so sorry. Yes, they unwrapped Pluto, honeys, for Vorverp. Broken Symmetry asks, if dark matter was headed straight for us, would it pass through us? Yes. Yes, it would. In fact, you probably experience dark matter particles going through your body on a regular basis. This is that whole issue of things that don't interact most of the time don't interact. So you are a giant bag of water, which means occasionally something might interact with you, but in a non-cancer forming kind of way, probably. It takes a lot to get neutrinos, which are also passing through you all the time, to get dark matter, which we've never been able to detect, to interact. And so they're going to try deeply cooled xenon gas, that minus 100 degrees Celsius xenon gas, or in this case, xenon liquid. Hopefully will do the trick. And when it interacts, it gives off a flash of light. So it's that flash of light we're going to look for. Is dark matter distribution even in the galaxy? Yes, there is a halo of dark matter that is densest in the center of our galaxy and expands outwards. This means that our solar system has roughly an Acme brick worth of dark matter within it. Is our gravity affected? No, because there's so little dark matter in our one small volume of space. In order to be affected by dark matter, we need to have a lot more of it in our galaxy. People have gone looking for the effects of dark matter within our solar system and haven't been able to measure those effects so far. Yeah, it is so frustrating that we're not able to see it. It's true. It's true. I'm so sorry I screwed up the pictures, folks. But now you have them. Now you have them. Okay. Do we have any other questions? Is dark matter what comes out of dark holes? I don't know. I don't know. No one knows what dark matter is. Other questions? So tomorrow, Annie will be here doing a rocket roundup. Thursday, which is Halloween, we are going to thank you, Trekker Kev. Grabbing, hi, come around to the other side, baby. Come over here. No, you just want to come up in my lap. Okay, you can do that. You're a good boy. Yes, you are. You're a good boy. Thank you for the bits, Trekker Kev. Thank you. So the plan is tomorrow is going to be our Rocket Wednesday update. Then Thursday, we're going to be going back and forth between a Japanese launch event and the daily space. So Annie and I will be tag teaming it and switching the stream back and forth between our two sites. Thursday is also Halloween, so there may be costumes involved. And Friday's Friday, we will be doing Astronomy Cast after the daily space. And this week's topic I'm trying to remember what this week's topic is. I don't remember what this week's topic is. I just don't. That's embarrassing. It's that kind of a day, folks. So, on that embarrassing note, with this embarrassing episode, I'm so sorry. I am going to go record our podcast and hope that it goes much better. Thank you all for being here. Thank you for all that you do to support us. And today is Tuesday, so I don't think we have any other live streams today. This has been the Daily Space. We are produced by Susie Murph and come to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. The Planetary Science Institute is our institute. They are a 501c3 nonprofit dedicated to exploring our solar system and beyond. This means that your bits, your subs, your patronage at patreon.com, which is really the best way you can support us. All these things work together to keep us going and allow us to pay Susie and Annie a wage, a living wage, a halfway decent wage, all because of you. And I clearly have had both too little sleep and too much caffeine because I cannot remember the wall of text. So thank you all for being here. And there will be on my personal channel story time this evening, Broken Symmetry. This is my day job. So I will see you all later on over on Discord. If you haven't thought to join our online community, well, consider giving it a try. We have regular conversations about science, science art, citizen science, and random science-related memes and products. So check it all out. And I will see you all tomorrow. No, I won't. Annie will see you all tomorrow. So wherever you are in the world, we are going to raid Oh Bother in just a moment. But for now, please have a fabulous morning, evening, and afternoon, and I'll see you on the other side. Bye-bye.